Welkom bij het webinar van Itanex en AGA. Mijn naam is Simone van Loon en ook aanwezig is Jacob. Allereerst wil ik samen met u verifiëren of het webinar goed te verstaan is. Als u mij kunt horen, kunt u op de knop Raise Your Hand klikken. Die staat aan de rechterkant in het scherm. Oké. Nou, het lijkt goed te gaan. Overigens kunt u niet zelf spreken, maar u kunt wel wat vragen stellen via het scherm. Wij zullen niet in de gelegenheid zijn om al uw vragen wellicht te beantwoorden, maar wanneer u vragen heeft kunt u natuurlijk ook achteraf altijd contact met ons opnemen. Deze webinar doen wij samen in samenwerking met AGA. Alvorens te starten zal ik eerst even kort uitleg geven over Itanex en daarna over AGA. En vervolgens geef ik het woord aan Jacob van AGA voor de verdere uitleg over Sustainable Design Pro. Jacob zal verder gaan in het Engels. Ja. Itanex is een multidisciplinair adviesbureau op het gebied van BIM, van ontwerp tot aan realisatie. Wij helpen u om het meeste eigenlijk uit uw BIM-modellen te halen. Itanex heeft eigenlijk vestigingen over het hele land en bestaat sinds 1996. In het beginsel waren dat vooral CAD-werkplekken en we hebben meer dan 6000 CAD-werkplekken in Nederland geïmplementeerd. Vervolgens werd het veel meer naar richting BIM en proberen we het meeste met u uit de BIM-modellen te halen. Met onze kennis, met 40 medewerkers, met onze kennis van proces, materie en product, helpen wij uw projecten te verbeteren. Wij zijn een geautoriseerde partner van Autodesk en bevinden ons in de top 20 van EMEA. Dat is Europa, Middle East en Afrika. Naast de software van Autodesk hebben wij zelf Smart Revit en het merendeel van u zult dit ook kennen. Dit is een schil om Revit heen waarin wij uw processen willen versnellen. Ook Sustainable Design Pro, waar het vandaag over zal gaan, zal meerwaarde bieden voor uw projecten. AGA is een ontwikkelaar van Revit add-ons met meer dan 5000 licenties in meer dan 79 landen. AGA bestaat sinds 1991 en heeft meer dan 20 werknemers. Het doel van AGA is ervoor te zorgen dat u als gebruiker meer profit haalt uit uw workflow en hiermee wordt ingezet op het versnellen van uw workflow en het wegnemen van verspillingen. Dan zal ik nu het woord geven aan Jacob van AGA. Jacob, you can switch your screen to start with your presentation of, yeah.
Thank you, Simone. Thank you for such a nice presentation from you. And here I am, Jacob from AGA CAD, and today I will speak about some kind of tools that will help you to do the green BIM, actually the Sustainable Design Pro. So this tool is located in our bucket, the flower of our tools. So we have the Sustainable Design Pro that is created for calculating heating and cooling loads, also the energy per season, according national standards, according the ISO standards. I will a little bit introduce all of these tools. What we have the BIM Tree Manager for managers of BIM project. Also we have the MEP Engineering Pro that stands for Sprinkler, Diffuser, Heating and Hanging Elements. Also we have the Cut Opening Pro that stands for cutting openings around the MEP line-based elements. Also we have the fast documentation that stands for the quicker work with Revit. Also we have the Smart Assemblies. This is the new tool from us, so that goes for assemblies of various elements. Also we have the Wood Framing Pro that goes for wooden constructions, and the Revit Content Management Solution Smart Browser. So you can download the free version from our website, Smart Browser. But today, as I said before, I will speak about the Sustainable Design Pro. And I will start the presentation from the beginning, from the Vasari that is made from Autodesk. Also, I will switch that to Autodesk Revit, and I will make some kind of calculations in Green Building Studio, and afterwards I will make the exact calculations on our created solution that is called Sustainable Design Pro Green Building. And I just want to go into the Vasari and show to you what I wanted to. At the very beginning, I will do I will make some settings of the sun, so I can make settings for the solar study. I can use the multi-day, for example, for the winter. I can use wherever location. For example, for today I will use the Amsterdam, that is located in Netherlands, and I will use the multi-day dates and the time, for example, from 8 a.m. till 18 p.m. and all these parameters will be included into my calculations. So just now I just want to show you how can I calculate some kind of solar radiation that will be based on my building faces. And here I have the solar radiation simple dialog block where I can identify, for example, the units that I want to see and the type of data that can be cumulative data, average data, or peak data. So I will use this cumulative data, and I will analyze my building. So the Vasari solution is asking me, do I want to perform my calculations that will be based on all masses and faces of this mass building, or I can use only a few faces on this building. So I will use the first one, and here I have a simple color scheme that identifies the kilowatt hours per square meter. And what I can do with such information, I can export all the information to the Excel file, and I can use that, for example, for further information. Also, I will rotate, for example, this building by 90 degrees, and all the information will be recalculated just in a second. And as you see, we have a little bit different scheme here. Also, I can export all the information like a second variant here, and I can do some manipulations with them using my Excels, for example, I will use here. So I don't need these cells here. I will hide them, and here I have the cell that is named insulation value. So I will sum up all of these numbers, all of these insulations, and I will get the value, how much kilowatt hours per my building I will get from the solar path. Also, I will open the second variant that I saved, and I will copy this one to get two different variants and to calculate the difference in between the rotation of the building and the rotation and the solar gain per this building. So as you can see, the first variant gets more solar, more sun, more kilowatt hours per square meter than the second variant, and we can calculate, for example, how much it will be. For example, I will minus from 100%. I will minus this one by 100, and I will divide that by this number, and as you can see, I get 11% difference in between these two rotations. So I can assume that my building should be rotated not in such a way as the last one. So I can rotate it backwards by 90 degrees because solar gain from such a positioning of my building will be much better than before. After this, I can use the windrows that can show me how windy is Amsterdam for this moment. I can use, for example, only winter time, and I will get that the most windy places are from the southwest, and I can place all the information on my building. As you see here, that's my building, and I can place that here under my mass building that is placed in Vasari. Just a second. And now I will know from which side from my building all the windy days will be. So I will assume that these places that will be should be more insulated than the other parts of the building. So I can turn the wind tunnel here to check all the situation, how the infiltration will be in my building. For example, I can rotate a little bit my arrow of the wind, and I will do the simulation in 3D view, and I will use the flow lines, for example, and just in a second we will see. So we can check the windy places of this building, and for example, I can understand that in this part of the building I will get the suction inside of the outside weather, and here I will get some kind of infiltration. Of course, I can use the different 3D views to check the situation. As I said before, here we will get the suction, and here we will get some kind of infiltration into the building. So after such design options of my building, I can turn into second my software that is Autodesk Revit. Here I have the same mass model that I showed you before in Vasari, and I can use this mass model for concept calculations of energy. So I will use the analyze tool for masses, and here I have the mass of my building, and as you see, I have some kind of windows. I have all the needed information for the concept model, and I will go back to the Analyze tab, and I will use some energy settings only for conceptual construction. So I can say what kind of conceptual constructions I will use for such a building. I can use the lightweight constructions, the high mass constructions, and many more things here. After such identifying of my energy model, I can press Run Energy Simulations, and the Revit and the cloud services will calculate the energy of such a building. But before I want to speak about the element model, I can use not only the mass model, but I will use the element model where I have not only the masses, but I have also the floors, roofs, walls, ceilings, and many more things here. And I can calculate again the energy using different values from here. So I can use now the building construction set will be very nicely shown here in this dialog block. So here we have the roofs, the walls, the ceilings, the skylights, and many more things. But that's a pity that we have only the constructions that goes from America, from ASHRAE standard, and we don't have our needed categories or analytical constructions. But where's the possibility to write some needed information into this part of Revit? So as you see, I have the A-class roof, I have the exterior wall, I think so, by A-class wall. So all this information could be written into XML file that is placed in your program files, Autodesk Revit 2015, and the construction XML. I will open it to show you fastly. So that's the XML. There you can find, for example, so I just copy one sentence, and I change my needed information. For example, I change the name of such construction and the U value, and afterwards my Revit will recognize these constructions as itself. And after such description of my building, of building infiltration class, of envelope, and many more things here, I can press again run energy simulation. But I don't do that because I have these calculations inside of here, and we will get these simple results. For example, for element mode, for mass model, and here we will find the building for performance factors, the life cycle assessment, also the annual carbon emission, the annual energy use cost, and many more things here. For example, you can even find the monthly heating loads, the monthly cooling loads for such a mass or element models. But that is not all from Revit what you can find, because you can open such a project in Green Building Studio, that is the cloud-based calculation platform, and here you can find all the necessary information. Now you don't need to rotate your building, because this solution, this Green Building Studio, will rotate your building, for example, by 45, by 90, by 135 degrees, and it will say what amount of energy this building will use when it will be built in such a place like Amsterdam. So we can check some information here inside of each of these design options, and here we can find again the energy, carbon, and cost summary of these two elements. Also, we can get the annual energy. We can find some kind of renewable energy potential, like photovoltaic potential, natural ventilation potential. We can check the energy and use charts. Also, we can check the water usage. What will be the water usage in this building accordingly the building type that is assigned, like living house or office building. It doesn't matter. So this house will have the value of persons per 1 square meter, and it will calculate the liters per year, how much it will consume. Also, we can find here the photovoltaic analysis for all the building constructions. For example, if we will place some photovoltaics on the roof, how many we will make, how many of energy we will make, and how the potentially we will save our money for such a situation. Also, we can make some kind of design alternatives, and we can change the information of this building and get the other calculations here. All the weather stations and weather information will be placed here as well, and you can find all the windroses, all the humidity factors, all the temperatures, and all needed information according the place that you live in. And after such like conceptual calculations of energy, we can go into the real building stage. Then when we will get the as-built building, and here we can use. I hope everybody was trying to get some heating and cooling loads using Autodesk Revit calculator here. So here we have the analytical model. Here we have some some parameters that we have to identify, but I try to do that as much times as I remember. I never get the real values here. So the possibility how to calculate the heating and cooling loads is building energy. This is our created solution for calculating the heating and cooling power, also the heating energy for 1 month, for 12 months, for heating season, and get all the information not only into the Revit model, but also into different exported files like Excel. So this building energy solution can help you calculate energy using different standards, as I said before. So we don't need to use the Revit calculations that is based on ASHRAE standards, because we are in Europe and we have to calculate according ISO standards. So I will use here the ISO standard that stands for Europe. I will create shared parameters for this building because we need new parameters here, like each of these spaces will get new parameters for power, for energy consumed, and many more parameters we will get here. And afterwards we only have to calculate and to identify all the parameters using this building energy solution. So I will press the project data button, and here, as you see, I have two different cities, two different locations, and today I will use the Amsterdam, and from this location we will get the temperatures, average temperature per year. Also I can identify the shielding class that will include some kind of factors for the calculations, and I can identify the shielding class, for example, no shielding, heavy shielding, and moderate, the middle one. Also I can identify the infiltration, how windy and how the wind will get inside our building, and what will be the infiltration. The infiltration will be calculated according to the tightness of the building. If we will have the low tightness building, so we will get the infiltration air change 0.42, but in some reasons we have added the design air change when we will have difference in between the inside and outside 50 pascals, and we will get six times changed air inside the building using such a value. So we can find needed parameters here. Also we can identify the building type. For example, if I have the single family building, I will get the set point temperature for winter, set point temperature for summer. Also I will have the area per person, so the solution will calculate the average heat flow from one person, and it will assume what will be the count of people inside such a building. And here we have more parameters for the calculations that is taken from ISO standard. Also we have the natural ventilation information here for air change per hour here. Also we have some kind of additional parameters, for example, for the building that has more than 5 floors, we will use such a correction factor. For example, if we will have this is correction factor for location and for orientation of the building. If we will have the construction on south or west, we will use such a correction. Also we have the heat recovery unit that will assume the airflow inside the building or inside the spaces, and the outer temperature you can change for the calculation. So it's almost everything what you have to do before starting the calculations, but you have firstly identify the constructions. For example, I will use the door construction, and here I have the door. For example, I can select the column, and I can get some information according these doors. For example, I can use the double glazing doors, I can use the solar radiation reduction factors, and I can use the solar protection factors like FC. And you have to do this information for each of the of your construction. Also, here we have the psi value that goes for thermal bridges. Here we can identify the connection in between the wall and the window. Also here we have identified this, and all the information will be included into our calculations here. So all the information can be exported to the Excel files. And as you see, we will have all the needed information in the Excel file, and you will be able to change some values here or to change some values in the project. And this is very, very, very nice because we can use the calculations for heating power, for cooling power, for heating energy for 1 month, for 12 months, and heating season energy. For example, if I will use heating season energy calculations, I can identify here when the heating season starts, then the heating season ends, and the heating season days. And afterwards, I can press to calculate the heating season energy. So I just calculated before this webinar this values of heating season, and I have placed them down here. So for the first variant, here I have all the calculations for each of the space. Here you can see the level where my space is placed. Here is the space name. Here is the number, here is the power of this space, and here is the consumed energy per heating season. So this is in joules, and I just converted that to kilowatt hours, and I have something like this of kilowatt hours per year. And the second thing what I changed, I changed the values of my doors to, as we have here, U value 1 we had, and now I will change that to another value like 0.5. And all the doors will have the U value of 0.5 now, and I repeat the calculations, and I get the second variant here, which has less consumption of energy. And I want to show you the calculations of the payback period. For example, I have the electricity consumption for the first variant here. I will find it here. Okay, I will copy that. Also, I have the electricity consumption for the second variant. So here I have the price of electricity that I assume that you have in Amsterdam. It's like 23 euro cents per kilowatt hour. I was asking my friend, but she told me that she don't know. But I assume that this price is almost good. So I will use these values here, and I will use, for example, the investment. I calculated the investment that it will be 15,000 euros, and also we will get some kind of expenses here. And as you can see, our project, the change of our doors can be paid back after 3 years. And if we will get like 7,000 for door after 2 years. So this is very, very simple financial calculations that can be made using our building energy possibility to export all the information to the Excel. So that is the whole solution that I suggest you to find and to look and to try using Autodesk subscription, Autodesk products like Vasari, Autodesk Revit, and Green Building Studio. And also I strongly recommend you to try this solution, building energy, that can calculate the energy and the powers of this building. So that is all from my part, and I just want to say thank you for all of you, and thank you. And you can find us by the emails. My email is jokubas@aga-cat.com and simon.wanloon@itanex.com. So
Yes.
if you have more questions, or if you have questions, you can write now to the GoToWebinar dialog block, and I will try to answer them fastly. And if you will have some kind of questions in the future, you can contact us. Using these emails.
Yes. Okay. Thank you, Jacob.
Thank you, Simon.
Okay.
So I'm still waiting for the questions, but I don't see any.
Mm-hmm.
So thank you again, and if you will have any kind of questions, please contact us straightly by these two emails. And have a nice day.
Yes.
Bye.
Have a nice day. Okay. Bye-bye.
Bye-bye.
Bye.